recording. Okay, good. We are good to go whenever you are.
Sure. So for those who don't know me, my name's Clifford. I'm the head of global ecosystem over at Dynex. I also manage the securitized Dynex in conjunction with our ethical committee. And some people want to know why, we have an ethics committee. Well, for us, we believe that, quantum without some guidelines, some barriers might actually be a really bad concept. So we believe that an ethical standard has to be applied when something like this is available for such a low barrier to entry. So, the way that we look at this, it's about making sure that while opening up the doors to people to use this technology, um, doing it in a safe environment is top priority for us.
Absolutely. It's a lot of power, and so it needs to be managed to some capacity. Could you briefly kind of explain what it is that Dynex is actually doing for people? Because I know we've talked about it a lot, but it'd be good starting point.
Those who obviously hear that we say that we're quantum, right? There are a couple of different types of quantum systems out there in the world right now. Obviously, the one that most people are familiar with is obviously physics-based quantum computers, right? They're big, they're bulky, they take up the size of a building. They have to be chilled down to absolute zero, and using superconductive metals and so forth, right? But there are other alternatives to quantum that are being researched on a daily basis. They have been for nearly a decade now. One is a neuromorphic approach, which will allow you to, instead of it being physics inspired, it's biology inspired. So, things like neural networks, for example, work really well on a biology inspired network. And the best way to describe what we do is, so we have a mineable layer one, right? That's all the GPUs that are connected to us. There's around 52,000, something like that on the network right now. We are able to emulate a quantum environment directly on the RAM of your graphics card. RAM by itself is super fast already. And some GPUs now are, absolutely ridiculous for the amount of bandwidth that you can actually put through memory. So we're able to create this artificial environment that works just in the same way as a physical quantum PC does, and allows us to, in essence, run quantum on traditional hardware. It's actually, something that we're very proud of that we've built. The quantum annealing is really up there. So we took a lot of what D-Wave was building with their what they call flux qubits, right? Or what we call synthetic qubits. Rather than it being a entangled physical qubit, like in a traditional quantum, we synthetically create our qubits. Now, it's not a one-to-one direct comparison. We've never said it is. But the qubit processing for us is more along the lines of what D-Wave and how D-Wave calculate their qubits. They have around 5,000. We have quite a considerable amount more. The reason for that is just that our distributed network is quite big. So, of course, brings the benefit of we just have a lot of resources available to us. So we can probably build up a good, 500,000 qubits of work of compute. But that's not a direct comparison to 500,000 physical qubits. There's not even a real way of conversion, unfortunately. I did try and ask the boss to make sure I wasn't getting this wrong, but there's no direct apples to apples comparison because certain types of qubits are very different than what qubits are considered for physical quantum, or universal quantum. So yeah, but we're able to emulate that, and it just allowed to really run any kind of quantum-based algo, whether that be simulated annealing for the lowest energy ground state or for actually doing quantum gate-based calculations.
Okay, so just so that I'm understanding it, there are several different ways that qubits are being created, several different models that people are adapting as because it's such an emerging field, there's so many different ways people are approaching this problem to find solutions. And you guys are using current infrastructure that's already available out there to create simulated or like synthetic qubits.
That I know of off the top of my head, research of synthetic qubits and using classical hardware. One is obviously us. The other is D-Wave, which we're completely interoperable with each other with 3 lines of code change. And the other one is now who's really playing around in that industry is Google. To be fair, you recently probably read about Willow, and that's taken a very similar approach. That is silicon-based quantum processing. So it's not something that has never been heard about before, for one. But it's definitely something that is becoming more and more researched.
Yeah. I think ultimately, as long as it actually works, that's what matters, right? And so that's a good segue to get us into the demo. If you're okay with sharing your screen.
While we're waiting, maybe I'll give you a bit of an update around, Apollos. I know that there's been some, should we say, some rather large discussions. So while we're waiting for you to get the screen done, obviously, I'm sure that there have been some people who have heard and read uh, Shay from Casper's uh, comments. And obviously, you've probably seen Sumi's responses to that. Now, obviously, I respect Shay. I've actually met Shay in person. He's a really nice guy. He's very, 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 don't like using the word brainy, but he's very smart, right? I know I respect that. But some of his ability to do the research was a bit the shame for me. So obviously you don't want anyone going off thinking that they've got to defend Dynex for us. We don't want to cause some sort of incident here, right? We are very happy that Shay reached out and had questions. We would have liked a more deeper dialogue with him before he decided to just do that, because I'm pretty sure with a deeper dialogue, he would have had a better understanding. But, um, you know, for us, there is no problem with people asking questions. That's why I'm here today, right? I'm showing you a demo, but equally so, I'm going to open up to some questions if people have any questions. I'm sure. Sorry, which one would we like to do first?
I personally would love to see what you showed me yesterday as far as the quantum protein folding, but I know that there was a lot of questions about the race simulations. I don't know if you got permission to share any of that information.
Obviously, we can't show too much about that at the moment. That's still very much an ongoing project that isn't cleared to sort of demo in front of people, because obviously they're a paying customer. But I've got some bits that I can show you, and I can talk the rest of the part for that, no problem. But obviously, yesterday we had a chat, and you said you were really keen on obviously protein folding, because protein folding is considered quite a task, right, for any kind of compute, whether that be classical in the traditional sense or quantum, because when you're doing protein folding, there's a lot of variables to consider, right? And obviously, the more complex the protein, the more you have to fold it and the more you have to compute it to where it is. So now I'm just going to show you the result for the second, because I want to explain this, right? So this is the kind of output that we get once it's run, right? Now, in a real world scenario, you're not going to have it go back into a grid like this, right? This is just for a proof of concept to showcase that it can be done, right? Now, normally you take this, you would put it into another program that the company in question would be running, and then that would take the protein fold and break it down into however their algorithms work. So obviously, I just want to make sure that you guys understand that what I show you on here are just proof of concepts, right? When we do proof of concepts, they're not supposed to be a complete piece of software for the end user. For us, it's about allowing the client or somebody like yourselves or, somebody just an enthusiast to be able to understand the logic and the concept of step by step how we did it, basically. So yeah, I think the best way to do it now is probably give you a run. So let me explain a bit of this code. I think that's probably also helpful, right? Now, can you read this? Okay, or do you want me to zoom this in a touch? So basically, this is how you code Dynex, right? So Dynex is coded on a couple of different ways. You can directly write it in Python, which is what this is. You could write it in C or C sharp or C++. Obviously, you'd need to create the wrapper for Dynex to be able to do it, but Dynex will bolt into most things. And so when you build anything around annealing, right, you're building the the the, the cubo model, right? The quadratic. Sorry, my chest. Hang on one sec. I apologize. I'm just a little gas at the minute. But the cubo model, right? The idea is that cubo model is all the instruction sets for the job, right? But inside of a cubo model, I can place constraints to make sure that it doesn't go outside the boundaries that I want. Inside of that, I can also add punishments for how the annealer works. So if it goes outside of those bounds, it will effectively issue a penalty, and therefore the next go around as it's working out, it won't do that because the penalty was there last time. So it learns and understands. And then obviously once you create the cubo, right, and that's like, so we're at this point here now, right, where you basically creating the cubo, right? This is what I was talking about. So this to here, I'll highlight it just so it's a little easier. So these three lines are effectively the change that we need to change for D-Wave code to run on Dynex. So, for example, the only three lines you change is the model so that it can actually wrap it for Dynex. The sampler, because obviously our sampler is very different to D-Waves. And then obviously how to read that sample set at the end of it. And it really, if you're used to coding, right, and I understand that not everyone is, but if you ever are understanding a Python code or something like that, then you should very well easily be able to take up coding on Dynex and having play. We are looking into options for some sandbox and playground areas for users to play around and test. We're still working on the logistics of that, but yeah, let me give it a run and I'll show you. So you can see here, it's initiated the sampler. It's waiting for the reads. It's finished. And then there you go. It's finished. So, like you can see, it's fairly quick, right? And that's only because it's only working on a 7 amino acid chain sugar. 7 is not that heavy on the compute, but it's a great way to showcase what is possible, right? If I can turn it up and we can do like 10, 15, it's still going to look very similar in the output though, because obviously It's how it's presented in a plot, in a graph. Normally in a protein fold, you would have it in a 3D render so you can actually see where the proteins have been folded. Um, Obviously, it's not quite like that when you're doing a proof of concept, but
Do you think you could give an example for like the amount of time that it takes for Dynex to simulate something like a 20-fold or 20 protein? Oh my God, 20 amino fold versus traditional compute?
we drag raced a couple of GPUs just to see what the difference was, right? And it's very hard to do apples to apples because obviously when we fire up a protein fold, it uses, maybe 800 simulated qubits. How do you equal that out on a GPU set? But we've test run it with a few different things. And protein folding shows a lot of promise. There's a lot of research that needs to be done in quantum protein folding and a lot of refinement that still can come. But it's right on par, if not a little quicker, maybe 15 to 20% quicker right now. But that's an unoptimized piece of code, right? If you spend 6 months and optimized it for real heavy, like compute for, say, I don't know, 300 amino acid chain string, which is part of the human DNA strand, then maybe you might get 40% out of it faster. So it really does come down to how much you optimize the code overall.
Which is actually pretty extreme. If you think about like drug development, getting a 40% or even like a 10 or 20% increase in the amount of drugs that you can experiment with, like you're looking at a huge increase to margins for companies and such. So that's really fascinating. I like
Give you a really good example, right? So recently spoke to a company that might be looking at Dynex as an option, right? I won't say their name because obviously I don't want to ruin a good opportunity, but they're at a point where they're spending so much on normal compute that switching over to Dynex would allow them to hire two actual quantum staff who could code this on a regular basis and still be spending less money than what they are currently spending on traditional compute.
you're going to just improve margins for a company, it is a no-brainer. And then having Dynex available as a quantum as a service on AWS, it's like it's just plug and play to my understanding.
If you've got the right people in the right place, integrating Dynex is a very simple process. Obviously, that's not every case because there's a lot of times where, we have to really make some big changes to be able to bolt into something. But we're always up for the opportunity to integrate Dynex into any piece of software, right? We would love to have all kinds of different compute software that's out there with a Dynex, plugin attached to it to allow you to compute on our network. We'd love that.
It's a big future for sure. Are there other experiments or things that you could showcase here? And I think people probably have a good amount of questions. So if anyone wants to drop it in the chat, I will be more than happy to read them or even unmute.
If I running this one because we did this right really early on. I think this was right around February this year that we did this, right? I then went to Token 2049, right? And I got talking to somebody and he said, "Oh, I work for an airline manufacturer." I didn't realize it was the actual guy who wrote the original paper for Airbus for their quantum challenge. I actually got to meet the guy who wrote the requirements for this paper. So this is actually really cool because what this is, right, is an aircraft loading optimization simulation, right? So for those who don't know or may never have been on a plane, distribution of weight is super important when it comes to a plane because otherwise you cause an air stall and the plane will basically fall out of the sky, which is a really bad thing to happen, right? Nobody wants that. So when they come to working out all of the logistics of loading a plane, it's like playing a really big game of Tetris, right? Everything has to go in exactly the right spot to even out the weight on the plane. And what Airbus wanted to know was whether quantum algorithms could actually improve the accuracy, you know, and take complex size of object and actually optimize it for a loading pattern. And now, Dynex wasn't the first to do this. I believe IBM was. And then D-Wave, literally right after, did theirs, right? And then a couple of months later, we did ours. But you can, let me explain if I bring it down here a moment. Well, I know this looks really strange and it looks like a big block of black, right? But that's a good thing, because what that means is that the optimization has basically slotted in every piece of freight in a way that it won't move, it won't redistribute or anything. And so this is something that obviously is quite a unique solution to a problem, right? I never even thought of using a quantum-based algo to optimize a loading pattern for freight, to be fair. But it's a really cool concept, right? So Airbus put out this kind of challenge to quantum engineers and quantum coders to actually come up with an optimization pattern. And I believe now Airbus even utilizes this, not based on our code, but I believe based loosely around the code that IBM came up with.
Which is pretty, actually very impressive. Like the use cases, I don't think everyone really understands the extent of use cases because it is so new. But if any idea that you guys have when it comes to things that have different options. So quantum computing is really good at probabilistic determination with things. So if there's a litany of different ways that something could happen, you want to use a quantum computer in order to differentiate which is going to be the best.
Here's a perfect analogy for you. Right, there's a really complex maze there, right? Can anyone solve that in under 5 seconds? I would be too, right? But that's the way the human brain works, because your pattern recognition works in one direction at a time. Whereas when you're doing quantum, I can send out 50 unique entrants and exits and have it simulate the whole route all at the same time. So the whole concept of what quantum can do, optimal pathway or optimized energy ground states and things of similar options there are all obviously available when you're running any kind of huge computation. Now you could do this with a normal CPU or GPU. Take a lot longer, but it is possible. But then you get to a certain point where the GPU or the CPU just can't get there in time, or it takes hours, right? Because it hits a bottleneck. With quantum, I can just keep opening more and more tries all at the same time. So instead of, taking its time, we can have this finished in less than like 15 seconds.
For anyone that wants like a very simplistic understanding, from my understanding of it, instead of like a normal computer or like you and I, where we would be trying to solve the maze, and if we hit a dead end, we have to turn around and restart and figure out where we went wrong and do a different path. Think of a quantum computer having 1,000 different guys running the maze all at the same time. One of them is going to find the exit of the maze. The others all might get stuck, but because we're able to run all of the different routes in simulation at the same time, you find the solution much easier, which is why it's really good, a quantum computer, at breaking encryptions and algorithms like the SHA-256 everyone's semi-panicking about, although it's not really a panic, but you get it. They can try all the different numbers, all the different solutions. virtually at the same time.
Yeah. It's down to permutations. You know, those kind of things have a lot of permutations. But when you can run 50,000 permutations a second, suddenly those permutations get very small. So, that's what people are worried about when it comes to encryption. Now, I was wondering when we might have somebody pipe up and say about encryption, and things like, sure, or breaking of encryptions, Bitcoin wallets, all of those things will be possible when it comes to a quantum machine. Are we there yet? Well, that's a good question. Um, I'm not sure is the answer because we won't ethically even try it because to us it makes no sense. We have no interest in proving or disproving whether or not a really big quantum computer could break encryption. I also personally don't fancy anyone with 3 letters attached to their name turning up at my house. So, we do sensible quantum. We do ethical standard quantum. For us, it's important. So, but yeah, to say that encryption is going to need to mature and be enhanced in the next 3 to 5 years, I think that's probably the understatement of the century.
Yeah, and people have been working on it for a while because this has been very clear. It's just a matter of how long is it going to take to get to that point, and I think we're seeing it speed up exponentially again, as expected. But I'm curious. I'm sure you guys have some questions, so let me open up the chat and see if anyone has asked any questions here. Guinea is asking what has led to the dramatic increase of jobs performed slash month as compared to the previous months.
Sure. And we recently signed a agreement to run some quantum-based courses. Those will obviously have students running on them, running test jobs and all kinds of learning jobs. However, we recently had a couple of new clients who are actively using it quite heavily while they find their services out. But we also expect that to continue to grow as more and more people start using the service. They become, more comfortable using that service, and once more comfortable use of the service comes, like they realize that actually it's a real big benefit to them to just keep running. So that a couple of the new clients have really been pushing the boundaries to see what's capable.
I have a question. What is a job? Like what you just did where you simulated the protein folding, would that count as a job on the dashboard?
Correct. So anytime you run on the network, right, a job is created, right? Because that job has to be split up into many pieces and distributed across our network, right? The job is then picked up by each miner who then processes it and then sends it back to us, which is then reconstituted into a single output that you see on screen.
Okay. That's good. That's good to know. The more clients you get, every single task they have is going to be a job. So Frail would like to know how will you compete with Google?
These type of questions, you know that, right? I love these type of questions. So for us, right, we understand that mixing it with all the big guys in the industry, like your Googles, like your D Waves, like your IBMs, is not going to be an overnight thing, right? We're going to have to earn that. And we've already had some really incredible dialogue with some IBM engineers recently. Some really, really impressive dialogue with them. So we know that some of the companies are aware of what we're doing. How much they worry about us? Probably they don't worry about us at all at the moment. And that's probably a good thing for us, right? Because it allows us a little bit of peace and quiet to build our technology, to refine that technology, and ultimately have something that's comparable when we really do launch the Apollo, chip. Because if we bring out something legit that's compelling, that matches all these big guys, suddenly there won't be any way for them to ignore us because they will have it, basically right in their face.
Point, you've made a wave so big that you literally can't ignore it, which gets into another question they said, is there any kind of sample case if it turns out that you guys are better than Google? Do you guys have ideas for that?
Sing it from the rooftops, maybe. Big banner down the side of Google's building, right opposite Google's offices. Absolutely.
A question that's actually spot on for you. They say, I haven't followed Dynex, so this question might be dumb, but does Dynex work on quantum security as well or have any plans to?
Something that we very much realized early on was that with what we're trying to build, you'll end up with a huge amount of compute available, that will, ultimately become available on a very reasonable cost basis. So then you start in the realms of, oh God, if everyone's got access to it, how long before somebody uses it for bad things and tries to break encryption, right? We know that it might not be on our service, but how long before they do it on IBM or D-Wave or other things, right? Uh, that's something that we very much look at all the time. And yeah, we're looking at our own version of a quantum-based encryption methodology. I've actually started to work on the white paper. It's going to take some time to build that because it has to be peer reviewed. It has to go through the strenuous check to make sure that it's valid security. But yes, the short answer is yes. We're very much into making sure about quantum encryption.
I mean, it makes the most amount of sense that you guys would have the most knowledge on what is needed in order to keep it all encrypted. So it makes sense. When does Apollo chip launch?
Going to take a huge amount of time. We're going to be actively pushing to get this built. I've already personally had some conversations with fabs, to speak about how we fabricate it, what nanometer size we fabricate on, potential problems that they see when they're manufacturing it, because we need to use certain materials, that come as part of the process. So all of that has to be factored in. It takes a bit of time, especially with these fabs being so busy. Just even getting a conversation with them can take weeks. But we're not slowing down with Apollo. We want Apollo out as soon as possible because, quite honestly, Apollo is a culmination of all the research and development in Dynex in a chip, basically. So not only do we then have an offering of GPUs and a distributed blockchain network, but we now have a physical product that you can just plug in and use.
It's gonna be it's gonna be absolutely massive. I have a couple questions when it comes to the chip. It's twofold question. The first one is this chip gonna be something that I could like put into my computer that I currently have and have like a secondary motherboard or act as a secondary GPU? Um, yeah, is it gonna be something like that that you can integrate into a regular computer?
Yeah. So effectively, the first version will probably be on like what we call a daughter board with a USB Type C connector, right? So that because we're not going to be sure how stable they are first, right? Before they even get out to general market, they'll probably be on like revision 3 or 4 or 5 before you guys even see them. So the first versions are going to feel very rough. They're probably going to be socketed so that I can easily change them out, make changes to the design if we need to, like burn a connection or two if we find that it's causing problems. There'll be all these kind of very unique problems that are going to arise while we're building this. So before we release anything to the public that could be considered a monumental flop, we want to make sure that we build a piece of technology that will work. And then ultimately the retail version will be on a PCIe card, like your graphics card, that you would plug in and it would act like and I'm going to show my age now, right? But there used to be something called a co-processor in a PC, which allowed you to basically, have other alternative codecs, compilers, and so forth on the co-processor. Well, Dynex's system will work much in the same way, that it will coexist with your existing sound.
That's actually really cool that you're gonna be able to have it coexisting. And what what might be the price point at which these things start at?
Wow, that's a tough question to answer right now. I personally would love them in a range that's very affordable, right? If you're going to get mass adoption of any kind of piece of technology, first and foremost, it has to be affordable. So, yes, the Apollo might work out quite expensive, right? Because it's the first version out of the game. But each version subsequently that we release, we should be dropping the price to allow us to bring that price down so it's actually an affordable price. Now, could we get it down to the price of what a CPU costs? I don't know. Could we get it to what a high-end GPU costs? Possibly. So if you look at what roughly a 4090 might cost you in retail, that's probably going to be around where the price barrier is at the time. Because we'd want to make it at least affordable in that respect.
That's good. I was kind of expecting you to say like 20 to 50 grand or something. So that's actually
It would really depend on obviously materials that we end up using, how long it takes to fabricate. There's a lot to take in, but each version should get progressively cheaper because we want that mass adoption. And mass adoption comes when it's affordable to everyone.
exactly. C90 here is asking about potential like being bought out, Dynex being bought out. Would an ethics committee block a sale of the company here?
That's a great question, actually. I don't think I've ever actually been asked that question. So kudos to you for asking. No, you're absolutely right. So when it comes to technically a buyout of Dynex, the company, yes, the ethics committee would be involved in that consideration. And that could mean that they block it. That could mean that, for example, D-Wave comes along and says, "Oh, we'll take that," and tries to buy us out. Well, the ethics committee can come in and say, "No, thank you." For many different reasons. They might not appreciate how ethically, should we say, grey area that D-Wave is happy to work in. And I referenced the recent Chinese guy who decided to try break in a Bitcoin wallet and Bitcoin encryption using D-Wave technology. Made the news, that, by the way. Not a very good show for D-Wave, in my view. They should have better ethical standards. But if somebody was to come along with the right offer, could it happen? Honestly, that's down to the owners, but ethical committee would have a say in that, yes.
Really, really good question, C90. So thank you for that. I appreciate it. This is this is a lot. This is a lot of information. So I appreciate you, Yeti.
I always like having a conversation with the community. Most of, the community knows me as somebody that will sit there and talk your ear off for a couple of hours around Dynex if you let me. So, if there's questions, feel free to ask.
Hey, I have a question about kind of how the chip is actually working because when I looked into it briefly, and I did not do an extensive deep dive into it, but it was talking about using magnetic fields to influence it. Is that correct?
And yeah, we would need to look into superconductive metals. It's something that we're researching in now with a partnership of a couple of other advisors right now from two different fabs. They're lending us a hand with some technical parts that we need some assistance with. So, you know, we're not opposed to asking for help if we need it, right? These fabs know what they're doing, and if they offer to help us in a way that we can make sure that this technology works even better, then I'm all open for that. But yeah, we're going to definitely need to look at superconductive metals.
Yeah, cool. They're asking if you'll leak CZ's number because they're assuming he's investing in backing.
Oh boy.
Come on, guys, this is where we add the pressure. Yeti, like me, Yeti will crack under some pressure. Let's get some information.
So I guess then I should probably show you these photos from
I think you already know the answer to that. Let's switch over screens. Somebody asked what the safest exchange to purchase Dynex is. So you can do Dynex through oh, I forget the name of the exchange, but they just did wrapped Dynex as well, so you can buy it on Uniswap.
side, the wrap side, Uniswap obviously has Dynex available. You can find, obviously, please make sure you get the right contract and double check that it's the right contract that you're interacting with. Because obviously we know that there are plenty of fake contracts out there and people get themselves wiped out. So please, if you're going to interact with the wrap side, make sure you get the right contract address.
Yeah, it's important. The scammers are.
Our native side now, we're on MEXD, Gate.io, Biconomy, and Coinet, with a few others. We are working on some more tier one listings. To say that that gives me a lot of sleepless nights is an understatement. But we are actively trying to get ourselves sorted out on a tier one exchange as we speak. So there has been some progress on that recently. We feel confident that we can move forward with at least one right now. So we're very happy with that. But as most know, centralized exchanges work on their own time. Not necessarily how often we would like them to move. Well, unless you're a meme coin, and in which case they'll list you in the same day. Sorry. If I found a bit annoyed at meme coins getting listed then.
It's crazy. They'd just be picking up random meme coins to put on.
But it's frustrating at times that but it's to do with, they're running a business at the end. Keep in contact with pretty much them all every other day. So, I spoke to 4 just today. I spoke to 2 yesterday. So yeah, I'm always in contact. It's just taking time.
Bullish. Someone asked, will the Dynex chip give me the ability to play Doom?
It was the first thing that ever came to my mind when I got introduced to Dynex. And the answer is yes. Yes, it can.
Very excited over that. Everyone just said my ears have been blessed. Thanks, Yeti.
Honestly, it's one of the funniest things because when I ran it on the network, half of our mods just instantly messaged me. They were like, "You're kidding. You're not playing Doom on Dynex, are you?" And I'm like, Yeah, I am. When we released the Sandbox Showcase play for people to have a play around with Dynex, I'll see if I can modify it in such a way that you guys can at least play the first level of Doom.
That's cool. That's alpha, guys. That's alpha. I don't think anyone expected on the call. Is JNNN says Dynex is on Coinbase wallet, right? So the wrapped Dynex, from my understanding, would be.
Yes. We're still working on getting on more wallets as we speak. We've currently got a integration into Zelcore ongoing right now so that can take the native, the wrapped and the bridge all in one. We're also actively working on our own wallets right now for iOS, Android, Windows, Linux, and Mac. So not just the core wallets that we've got, but actual proper self-custody wallets for your mobile devices as well. And then I recently spoke to 2 hardware vendors about potentially listing Dynex on hardware wallets. And nobody knows that one yet. I haven't told anyone that I've been talking to hardware vendors yet. Obviously, the Wrapped is supported on pretty much anything that supports ERC20, right? So if you do want to go down the Wrapped route, you can then store it on Ledger, Tangent, anything that supports ERC20, you will be fine to store your Wrapped Dynex on. Might take a few bits of extra setup to accept a token that isn't known, but we actually published a whole load in our Discord, video tutorials for different hardware wallets. So feel free to check that out. Or if you check out YouTube, Serpent X Tech, he was the one who was kind enough to do all the videos for us. And he did all of the videos on his YouTube. So you can always go and check that out directly on his YouTube.
That's perfect. That's good. I'm a video learner, so that's good. Questions on the tokenomics. If you could kind of go through how the Dynex token's integrated into the business, and then the DHIP V2 that you guys just unveiled.
Sure. Sure. So we have a max supply of 110 million. Originally, when we first opened up Dynex on the blockchain, it was originally 100 million. Unfortunately, and this is before I joined, so I do apologize if I may get this slightly inaccurate. But as I recall, it was explained to me, there was a problem where straight away ASICs jumped on the network in the first month. And so what the team decided was to increase that by 10 million to offset those losses for everyone else, so they evened the playing field, so to speak. Obviously, so that means now we're at 110 million rather than 100. So we've updated everything. Everything's all, done properly. We did it with obviously the community knowing. And then, right now we have an emission curve, right? For those who don't know what an emission curve is, instead of like Bitcoin halving every 4 years, we have what we would effectively dub a micro halvings, right? So you divide it by 365 days of a year, and you can work out an emission curve that slowly reduces the block rewards that are issued out on the network. I believe we're at like 93 million, something like that now, that's fully out in the wild. So we've still got maybe, I think it's 12 months of emissions left. But obviously, when spot jobs are run, and I'm not talking about the subscription for the second. I'll get to that side in a sec. But when a spot job is run, so a pay-as-you-go job, the rewards of that job go directly into the block rewards. So if I ran a job right now and it cost 100 Dynex, you would see in our block explorer 100 Dynex going into that block on top of the 44 Dynex that the block reward is. So for that, you would end up with, a reasonable reward if you were solo mining. If you're pool mining, then the pool gets that, and then it's distributed across the users that are connected. Now, obviously, we also now run a subscription model. And how does that work? So with our subscription model, right, obviously there are Q nodes in place. We're not quite there ready yet with the release of Q nodes, but we've got a couple running, or I have as well. They're going through testing at the moment to make sure it's stable. But basically, every Q node that is connected is going to have to pay a Dynex gas fee that will effectively be paying the network via DHIP, or the Dynex Holders Incentive Program. Or once we get it finalized on the native chain, DHIP or the native chain, which is obviously a lot of the miners. So we're trying to make sure that there are incentives for both sides of the equation, right? If you run a Q node, we're actually going to pay in USDT rather than Dynex to alleviate some of the sell pressure, right? Because we know that companies or people that were running these services might need to sell on a daily basis. So instead of the Q nodes being paid in Dynex, they're paid in USDT stables to allow that sell pressure to not be there. So yeah, we've got still some way to go with our tokenomics. We have openly admitted we made a bit of a mistake with the aggressive emission curve. It caused quite a lot of Dynex to be out on the open market very quickly, which caused some issues. We've openly said that. We admit that we may have made a bit of a mistake in judging how fast we needed this to run out. And therefore, that's caused us some problems. But we're open to learning. We're not robots. We're just human beings here, and we are able to make mistakes. But fixing those mistakes and learning from those mistakes and bettering ourselves is obviously a very good sign of a very strong business.
I completely agree with that. Nothing's ever going to be 100% perfect. It's just a matter of iterations after the fact and being transparent and owning up to everything, which you guys do. Like, you guys are very well-run companies, so.
I think we had a chat about some other bits, didn't we, last night?
We did.
Yes. Well, I mean, there's quite a few people in here. So, I mean, maybe we should, I don't know, a couple of t-shirts? Maybe some Dynex?
I think the people in here are going to absolutely go bonkers for that. Some Dynex t-shirt giveaway right now?